software developers or students or just want to explore security in a sense, I think this is perfect for you. It's pretty beginner friendly, and we explore how we look at software development in the security perspective. So my name is Cher Boon. I'm a security engineer, a part-time faculty at SMU, and I play CTF under that banner. So yeah, what we'll learn today is what is parsing differential problem, how this affects us, and how can we address this issue. So I think some of us here are startup owners or wanting to be startup unicorns, and we all start with a single system, right? And or maybe some of us are working in a startup or a company of some sort. And the softwares we're working with could be as small as a single system, and over time it evolves into a very large system. And when you make it big, it involves different technologies, languages, because you just have different tech families spawning here, left, right, center, right? So as you proceed to have growth, you start to introduce probably a gateway, right, to integrate everything together, and everything is interconnected like microservices. So you could have a .NET at the very back end with Java or Django and Go. So all these services, they're all talking through either HTTP or gRPC or whatever. Like they are all exchanging data through a common interface. So all this is due to the path of least resistance to growth system, right? You are, let's say you are in a team, you're using Go, and then somehow the CEO or the product manager says, let's build this product, and they assemble a new team, and that new team happen to be coding in Python, for example. You can't expect them to do it in Go, right? It's a reality, right? You just want to make the system work and serve it as fast as you can to get shorter time to market. But what could go wrong here, right? So if let's say we have system 1 and system 2, given the request, right, of these two, right? First you have John, the second you have Mayer. Assuming that system 1 is Go and system 2 is Django, what could go wrong here? So let's look at the fundamental simplistic code that you will have in the Go and the Django, I would say HTTP microservice. Right, so on the top you can see there's this .get, and the bottom you see there's a .get as well. Both are similar, and both can be found in the official documentation. So what would happen is, the Go system, right, after going through the gateway, will evaluate foo as John. Say, okay, no problem, let's pass it on to the next system. And system 2 will evaluate as Mayer. Now imagine I'm an adversary, right, and I want to cause harm to your system. I will take advantage of this inconsistency and inject probably SQL injection as shown here. So let's take a look what's under the hood, right? And the Go documentation, Go gets the first value that's associated with the key, while in Django, it gets the last value associated with the key. So that means this is how it looks like to the system when the whole entire request is being made from the user, right? Now this is called the parsing differential problem. It originates way back from this Langsack theoretic approach where systems have difference in mutual interpretations of the components. So this is not something that's new. It's been mentioned in many articles and many CVEs as well. Right? You can have how to exploit parser differentials in GitLab by Yuan, I can't write the last name. And there's a Boon function which he makes a tremendous video about it. And then on my favorite hacker researcher, Orange, who talked about it in his Black Hat talk in 2018. And one of the books that I read like a Bible, Tango Wet by, there's Mikhail Zlotowski. And if I could quote another guy, a local guy, his name is Eugene, also go by the name Space Raccoon. His recent DevCon talk on iCalendar exploit also includes issues with parsers and how they're being exploited due to the difference in how RFC was interpreted in those applications. So this is a list from this payload of all things, GitHub, which I contributed to it some time back. And I kind of collated all the different ways how systems or subsystems would, systems and libraries would interpret the variables, right? Which one would they choose, the first or last, or they see everything as an array or a list, right? So this, at least you can see. So why this occurs, right? So we have this, unlike this URL or URI RFC 3986, right, where it defines how you should read a domain name, how you should pass a domain name. There isn't an RFC for variables in the URL, or even the request body, or even HTTP body per se. Right now, there isn't, as of today's talk. So this creates a space, or rather the opportunity for problems to arise from such root causes. So, like I mentioned, apart from the URL variables, it can happen in your request body. It can even happen in your HTTP headers. And I would like to point out that HTTP headers is also a whole world of crap over there, because you can have canonicalized, uncanonicalized headers as well, which, the headers can jump up. Some systems, they would uppercase the whole entire header. Some systems, they will lowercase the entire header. Some systems just read it as it is, right? So I've read vulnerability reports about systems not reading the headers because, or rather parsing the headers correctly, which allows some sort of a bypass leading to a remote code execution. And one example is one of the GitLab ones, right? So because of the headers as well. So what can we do about it, right, is be aware of what we are using, right? Know what is our system, include test coverage for such repeating variables to assert that this weird behavior doesn't happen, or normalize the data using an API gateway so that your API gateway will strip such things. Now, there have been, one thing that I left out here is that we can just use JSON or XML or anything, right, that could also help you normalize your data because how the library works. So, before I end my talk, let's say, it's a bit fast, but if there are any questions, you can just ask also, right? But before I end my talk, we talked about web systems and all, right? The next step I'm taking forward to is actually the cloud. Today we have so much cloud services and from different providers. What kind of parsing issues could this cloud provider give us, right? So that's one thought I would like to share with you to think about next time. Thanks.
So repeating his question, is there a typical exploit that, that in parsing, sorry, repeating for people who are streaming?
Okay, so usually such exploits, right, will be used to bypass restrictions. So you have a blacklist or whitelist, or you might even want to bypass firewalls, right? So one example is you want to bypass a web application firewall, custom built, right, built by your in-house team, you're not using cloud providers one. You want to bypass filters that's been implemented in libraries, right? Using such methods, you can bypass those firewalls or even blacklists. Yeah.
Are there any more questions from the crowd?
Yeah.
Else, there's one question. Oh, sorry.
There's one there.
Cool. You want to shout it out first? I'll repeat it for the.
Yeah, so that was one of the mitigations at the recommendations, which is to use normalizing the data maybe through a gateway, through GraphQL, through gRPC, anything, to determine the final form of the data before passing it downstream to the atomic services.
Any more questions? Cool. So there's one question from online, anonymous, but Are there strategies that can be adopted by SDLC teams to avoid the parser differential issues?
So I think first you have to, from a macro level, you have to understand what you're using in your systems, right? If you are a very large team in a very large tech company, then it's really hard to track those. But if you're in a small team, you can really start by understanding what your systems are working with, and along the way, implement subsystems that will normalize those values. Because even you have new system popping up, right? If you normalize the value at a certain point, you would eliminate that problem, or you probably just use JSON or anything that would just stop this from happening. Yeah.
Any more questions? All good? Can we give another round of applause? Cool.
All right, next speaker.